Hello, I'm Tim Precella with my college algebra class, working on the final exam review sheet. We're going to start at number 23 today. For the given functions f and g, find the indicated composition, and they give us two functions. F of x equals the square root of x plus 8, and g of x is equal to negative 4 divided by x. And notice the composition they want us to find is g composed with f. So let's make sure I copy the problem. Oh no, this is the work we just finished doing. Let me throw that away. So here we are. Find the indicated compositions. So they gave us f of x equals the square root of x plus 8. G of x is equal to the negative of 4 over x. They want us to find g composed with f of x. When we were finding compositions at numbers, like in problems 21 and 22, a composition of functions at a number, the final answer is what? A number. But a composition of function at a variable, you expect your final answer to be a variable expression. So, let's write this. Which function's the outer function? G is on the outside. That means on the inside we have f of x, and we know what f of x is. They gave us f of x. That's the square root of x plus 8. So tell me in words, what is this g of square root of x plus 8 telling me to do?
Square root of x plus 8, where you see an x in the g.
Okay, so everywhere you see an x in the g, you're going to plug in. That's a negative 4 over, plug in a square root of x plus 8. And you can stop right there. They're not going to make you rationalize to get the final answer. You would have been told in previous math classes that it's radicals and denominators are just awful. In reality, they're really not. There are certain circumstances, especially in my business calculus class, where the radical in the denominator is much more desirable than rationalized with the radical in the numerator. If you rationalize this, by multiplying above and below by the square root of x plus 8, you get a negative 4 times the square root of x plus 8 all over just an x plus 8. Certainly this boxed in form looks better. So let's see. Hopefully that's the one they have on the test generator. And sure enough, it looks like here it is, D. Same instructions for number 24. They give us two functions. F of x equals the square root of x plus 2, and g of x is equal to negative 1 over x. We're asked to find f composed with g of x. So, which function's on the outside? F is on the outside. What have we got on the inside? G, and we know that g is negative 1 over x. So tell me in words, what is that saying to do? So we're going to go to f, and we're going to plug that in for x. We'll still have that plus 2 there, but we're going to replace that x with the purple negative 1 over x. And A, B, C, or D. Hold on. We push that up. There it is. And which one did you say it was? Is it number 24? Yeah, it's another D, isn't it? Yes, it is. Once again, those problems look worse than they actually are, because there's really, they're not requiring you to do any of the rationalization or combining the fraction and the non-fraction and then rationalizing. I tell you right now, if you did any of that that simplification that you saw in previous math classes, the end result would be much messier than what we have right here. Any questions? Number 25. Hold on. Number 25. There it is. Factor f of x into linear factors given that k is a 0 of f of x. Which of the following are two of the factors of f of x? Remember, they're not giving you the entire factorization because they don't want you to be able to just sit there, start multiplying out until you get back to the original function. Although I cannot imagine anyone would want to do that, but maybe they would. So they're only giving you two of the three factors. Well, what are we going to use to factor this function when they're giving us a 0? This is where we're using synthetic division. Remember, I've written the problem down already for us. Let's see. My brother's a smaller writer. He could work the problem out right out there in the little bit of space, but I'm not able to do that. So we have that k equals 5. And then notice the largest exponent in the function is x cubed. So we're going to need an x cubed, an x squared, an x, and then a constant term. What number is going to go here? 1. The coefficient of x cubed is 1. Here, -2. Here, -25. And here, +50. We skip a line. And how do I get the synthetic division process started? Okay, so we just bring down that 1. 1 times 5 is a +5. Okay, -2 plus 5 gives me a +3. 5 times 3, that's a +15. Okay, combined to give me a -10, I agree. 5 times -10 is a -50, and sure enough, what are we getting here? 0. They told us that k equals 5 was a 0. That meant that that number there had to be 0. If I had gotten 0, I know I'd mess up somewhere. Well, we took an x cubed term, we divided it by an x term. X cubed divided by x, what variable part should be the leading variable part in my quotient? X squared. It's one less than the largest exponent in the function, so we have an x squared, an x, and finally a constant. So let's start factoring our function f of x. First of all, what factor comes about from the k value? Okay, it has to be something so that when you plug in 5, you get 0. Remember, it's x and exactly the opposite of that k value. That's a +5, so a -5. There's the first factor. We still have x minus 5 times 1x squared plus 3x minus 10 is giving me that function f of x. We want to factor this into linear factors. That means we need to factor the x squared plus 3x minus 10. We know how to factor that. The x minus 5 I'll just bring down. X plus 5 and x minus 2. Do y'all agree with Chelsea? She got that very fast. I agree with it. There's the final answer. There's the entire factorization. But that is not what they want here. Here they're looking for, hold on, a number 25. They only want two of the three factors. They're not giving you all three factors, so you can't sit there foiling and then distributing to get back to the original function. So A, B, which one? Okay. First of all, does our answer contain an x plus 1? Certainly not. Okay. Does it, and y'all say, does it contain an x minus 2? Yes. Does it contain an x plus 5? Yes. So I agree with B. X minus 5 and an x plus 2? No, it doesn't have the x plus 2. And yeah, you're right, B. B is the only possibility. Any questions there? There should only be one correct answer, okay? That's why I was checking the program. You know this test generator sometimes messes up. And number 26, the same thing. There. So we make our little k equals 1. We make our little hook. There we are. And our variables, once again, we have, looks x cubed is a good one because it's not too big. Starting with an x cubed, an x, and a constant. Call the numbers out across the top here. 2, -3, -5, and 6. And then, so I'm bringing down the 2. So 2 times 1 is a positive 2. -3 plus 2, I agree. Okay, -1 times 1. Notice we're multiplying by 1. That's the nicest possibility. Here.
-6.
Here.
0. 6 and 0.
How about a -6 and a 0? Once again, that 0 is to be expected. We were told that this k value is a 0. That means the remainder has to be 0. So, what's the variable part attached to this 2? X squared. It's 1 less than the largest exponent in the function. Here. So we have f of x equals
X minus 1.
okay, x minus 1 times 2x squared minus x minus 6. And that 2x squared minus x minus 6. There's my 2 sets of parentheses. Let's factor that. I'll get us started. 2x squared, that's a 1x into 2x. I know that. And maybe a -2 and a +3. I agree. There's the entire factorization. There's the entire factorization, but that's not what they're looking for. They just want 2 of the 3 factors. So well, it's not A. It's not A that x, we don't have an x minus 3. It's not B, we don't have an x plus 1. Okay, so D, an x minus 1 and an x minus 2, I agree, it looks like D. Here, once again, we don't have an x plus 1, so I agree, response D. Any questions there? Okay. Now some exponential equations. This stuff should be familiar to you now because we're coming into the test 3 material stuff, and we were just taking, I guess 2 weeks ago today we were reviewing for test 3, so this should be more familiar to you, or at least more recent. So the instructions say, this is number 27 right here. Solve the equation. Now, let me make sure I didn't miscopy it. Yeah, there it is. So, what should I do? Okay, so we have a power raised to a power. So, a power raised to a power, you multiply. That's where you get the 4 times the -x to give you a -4x. And then, okay, for the first method we had for solving exponential equations, if you have a common base, you can drop the base, set the powers equal. So we drop the base, set the powers equal, and I suppose I'd move the 4x to the left, I'd move the 1 to the right. Combining the x's on the left, what am I going to get? Wait, I think it's going to be a 9. 5x plus 4x, that's a 9x equals, aren't y'all the class that wants the x's on the left? I think yes, okay, so I'm getting the x's on the left. Divide by 9, although I shouldn't, because y'all should get over those preconceived prejudices, but anyway, I'll humor you. To give us x equals 1/9, A, B, C, or D? C. And let me make sure that miscopy number 28. 16 to the x minus 2 equals 32 to the 4x. Same thing. So, friends of ours have, in their spare time, have taken to clicking on these videos, what they're doing in Houston, clicking on these videos to watch them and turning on the captions. Because if you turn on the captions on YouTube, it's of what they interpret me saying, all of a sudden I'll be saying Czechoslovakia in the middle of nowhere. It's just a meaningless collection of words. It's amazing. Do I really sound like that? But the YouTube caption thing can't understand my voice. Anyway, we need a common base. On number 27, we had a common base. Okay, now the common mistake is to think 32 you can write as 16 squared, okay? But 16 squared, I think that would be what? 256, certainly not 32. So you're right, we're going to have to change both sides here. And what did you say we'd use? 2, I agree. 2 to what power gives us a 16? 2 to the 4th, okay. 2 to what power gives us a 32? 2 to the 5th power, I agree. So we then have 2, distribute the 4, well, power raised to power, so you multiply. 4x equals 2, and I agree, the 20x. And then drop the bases, I agree, so you just have 4x minus 8 is equal to 20x. Okay, I'll move the 20x over to the left, combining it with the 4x that gives me. No, you see, that's not what I would do. I'd move the 4x to the right, okay, to give us 16x. I don't know why I decided to do what y'all wanted me to do and move those x's to the left. This isn't a democracy. We don't take a vote and then decide, okay, I'll do that. So it's sort of a totalitarian regime. And at this point in the semester, y'all all know it's best just to humor me, right? If no one's told you that, I'm telling you. At this point in the semester, it's best to humor your teacher. Okay, so, and that's true. You can take that advice to you for years and years to come. So, oh, by the way, what did I do? I moved the 4x to the right. 20x minus 4x gave me the 16x. Then I divided by 16 to give me a final answer of negative 1/2. Oh, was I recording? I shouldn't have said that. Oh, well. So this is number 28. Negative 1/2. Negative 1/2. Okay. You're getting life lessons here that you can take with you forever. It's just like when I tell my nephew to humor his boss, even if he doesn't think the boss is right. He needs to humor the boss and do what the boss says. Maybe the boss knows better. Okay. Another, solve the equation. Let's make sure I didn't miscopy. No, that's right. What do y'all think will be the first thing I do? By? Okay, so that square root is 7. That's the same thing as 7 to the 1/2. I think I was very consistent with exponentials and logarithmics. If I had a square root or any sort of radical, I'd write it using an exponent. And now, suggestions on a common base. 7 is a prime number. You're not going to change the left side, so you better be able to change the right side. And sure enough, 49 is the same thing as 7 squared. And now, powers raised to powers, we will...
Drop them.
We'll multiply the powers and then I'll drop the bases. So multiplying the 1/2, I get plus 2. You could use a 0.5x. You'll get the same final answer equals 7 to the 2x. And now this is where I drop the x's. Drop the bases. Generally, I do not drop the bases until every set of parentheses is drawn. That's when I then drop the base. That gives me a 1/2 x plus 2 is equal to 2x. Multiply everything by 2, I agree. We're getting rid of that denominator. That's going to give me, so x plus, be careful, 2 times 2 is a 4 equals 4x. Multiply by 2, the 1/2 canceled out, leaving us just 1x. 2 times 2, multiply by 2, that gave me the 4. Multiply by 2, that gave me the 4x. Now what? Okay, subtract x. You're humoring me now, aren't you? You're humoring me now. You know that I want to... Okay, so subtract the x. 4x minus 1x gives me 3x equals 4, which means x is equal to 4/3. This is what, number 29? Number 29, 4/3. Let's see, there it is. 4/3, response D. And number 30. Number 30, let's look at the instructions. It says, use the change of base rule to find the logarithm to 4 decimal places. Log with the subscript of the square root of 5 of 183.3. So, logs, yes, okay. So, what's the change of base formula? Oh, well, okay. What goes on top? What's going to go on top, though?
3.3.
Okay, so, and now, what logarithm do you want to use? Sounds to me like Moses is using the common log, but that's very outdated. I hate to say that, okay? So if you're going to use, if you're going to be more hip, I guess that's the word. If you're going to be more hip, what are we going to use? Natural log. I asked someone that went to graduate school with me, that's a programmer for TI now, several years back, saw him and asked, one of the things I asked was, why is the natural logarithm more popular than the common logarithm? And what was his response?
It looks cool.
That's what I thought, but he said no, it's a smaller base. For programming purposes, ln is log base e, 2.718. log is a log base 10. Programmers like the natural logarithm because of the smaller base. Take it for whatever that's worth, okay? And okay, and I forgot my calculator. Isn't that terrible? That is terrible. Who has a calculator? Can I borrow that calculator right here? Okay. Let's see. Oh, this is such a fancy calculator. Okay. So that's the natural log of 183.3. What should I do? Close the parentheses. Divided by the natural log. I need the square root of 5. And oh, this is that's very nice. Okay, it gives a little symbol there, doesn't it? And enter. How do they want us to round? To 4 decimal places? So I'm getting a 6.475.7. I agree. 6.4757. And let's see, 6.4757. That looks like response A. Any questions there? And I think I'll take a break right now.